If you ever spent an extra $10,000 to buy a diesel engine because you thought it was more durable and economical, then you have fallen into the most expensive trap in the automotive industry. The DEF technology you trust is actually the very thing costing you tens of thousands of dollars every year. It is the root cause of 43% of vehicle breakdowns today, all because of a single trivial sensor error. But the true culprit behind this isn't the car manufacturers. It is Washington. Those sitting in air-conditioned rooms, holding the power to suffocate your vehicle through lines of software code. This video will expose the truth about how Washington killed the diesel engine and turned you into a debtor of emissions regulations right now. To understand why the modern diesel has become a financial disaster, you must go back to the time when it was the pride of mechanical engineering, not a victim of policy. For decades, the diesel engine was not just a machine, it was the backbone of transport, the force that kept the economy running. According to reports from the DSOA, diesel once far surpassed gasoline engines in efficiency, saving between 20% to 35% in real-world conditions. This was not laboratory theory, but a result confirmed in the operations of transport, construction, and logistics businesses. A diesel engine maintained according to protocol could operate from 500,000 to 1 million miles without needing a major overhaul. This was a technical standard that remained stable for many years. But this status quo began to shift as emissions regulations were tightened under federal law. At the heart of this system is the Clean Air Act, the legislation that allows the U.S. Environmental Protection Agency, EPA, to set increasingly stringent emission standards. Regarding the goal, this policy aims to reduce pollution. But regarding implementation, compliance costs have risen rapidly and directly affected engine design. Instead of optimizing the combustion process to achieve high performance and low emissions at the source, manufacturers were forced to adjust designs just to meet testing standards. Engineering priorities were replaced by compliance priorities. According to a report by the SBA Office of Advocacy, EPA regulations impose a cost burden of over $2,000 per year per vehicle on small businesses just for administrative compliance and emission system maintenance. Engineers no longer design for maximum efficiency. They must ensure the system meets legal limits under all testing conditions. This is a structural change. Production costs increase significantly due to the requirement for additional emission control systems and related components. As a result, the price of a diesel vehicle increased by $8,000 to $12,000 compared to an equivalent gasoline version. At the same time, legal risks for manufacturers have risen markedly. A prime example is the case of Cummins, where the company accepted a fine of approximately $1.675 billion in 2024 related to emissions control issues. More than 600,000 Ram trucks were affected by recall programs and software adjustments. These figures show that regulatory pressure impacts not just design, but also directly affects operating costs and the production strategy of the entire industry. Manufacturers are forced to choose between maintaining technical performance and minimizing legal risk. In reality, the majority choose to prioritize compliance, as the cost of violation is far higher than the cost of product adjustment. The consequence is that the cost of diesel ownership has increased in all aspects: higher purchase prices, increased maintenance costs, and greater operational risks. Users have to pay more to own a more complex system that does not offer corresponding benefits in performance or reliability. Diesel has not lost its core mechanical capability, but it has been placed within a regulatory framework that causes overall costs to rise beyond the initial economic benefit. When costs outweigh the value provided, a change in user behavior is the inevitable result. The heart of the matter lies in a component costing only a few $100s, yet it holds the power to control the entire operation of the vehicle: the DEF sensor. DEF, diesel exhaust fluid, is a mixture of urea and distilled water, characterized by chemical instability under real-world conditions such as low temperatures or prolonged storage. When temperatures drop, the solution can crystallize. When temperatures rise or storage is poor, the concentration can deviate from the original design standards. This sensor does not evaluate engine performance. It only checks the fluid status and signals from the exhaust system. When it detects a discrepancy, no matter how small or whether it has actually affected real-world operation, the system triggers a mandatory enforcement mechanism called the Inducement Schedule. This is a pre-programmed coercive process. There is no choice for the driver. There is no assessment based on actual conditions. At level 1, the system limits the maximum speed to approximately 50 miles per hour, even if the mechanical engine is still functioning perfectly. At level 2, if the error is not handled as required by the system, the speed is further reduced to a crawl of about 5 miles per hour. This speed is no longer suitable for normal traffic conditions. At level 3, the system locks the ignition entirely. Your vehicle becomes a stationary block of metal, despite having no serious mechanical failures. The entire process is triggered solely based on sensor signals. No engine fault required, no mechanical damage needed. The critical point to note is that this mechanism does not assess operational risk. It only checks for compliance with designed emission standards. This creates a clear paradox. A secondary system has the right to directly intervene and suffocate the operational capability of the entire vehicle. According to data from the American Transportation Research Institute, ATRI, issues related to the exhaust system account for 43% of unplanned stops for heavy-duty trucks. This is the highest rate among all fault groups. It is not the main engine. It is not the powertrain, but the supplemental system itself. These incidents increase repair costs, increase vehicle downtime, and directly impact the business efficiency of the user. Users invest tens of thousands of dollars in diesel engines to buy long-term durability and performance. However, operational reality is now held hostage by electronic components and sensors with much lower stability. This is a fundamental shift. Operational control no longer depends entirely on the mechanical condition of the engine. It depends on signals from monitoring systems. And when a monitoring system becomes a mandatory condition for vehicle operation, any deviation, even a software error, can lead to a complete disruption of operation. The practical answer is no, if you consider the right to control the system and operating software. According to the Clean Air Act, any act of interfering with the emission control system is considered tampering and is subject to penalties. This regulation includes modifying control software, changing system configurations, or disabling emission-related functions. Ownership exists on paper, but control is restricted by law. Independent mechanics are bound by similar constraints, making access to original data in system repairs extremely limited. This creates a double barrier, both technical and legal. When the system reports an error, the only practical choice left is almost always the official dealership. As a result, the repair market loses free competition. Dealers have the right to diagnose, update software, and replace components according to the manufacturer's own standards. Labor costs here typically range from $150 to $250 per hour, significantly higher than the previous independent repair market. This price level is maintained due to the lack of alternative options. Since then, many small companies have also tried to circumvent the law by offering technical solutions related to exhaust systems, but all have been fined, with fines reaching millions of dollars. These measures eliminate nearly all repair services outside the manufacturer's official system. The result is a controlled shrinking of the service supply chain. The right to repair has not completely disappeared, but it is strictly limited within the allowed scope. Repair costs increase not just because the technology is more complex, but because the market no longer has full competition. This is a structural change. The mechanical parts still belong to the user's ownership, but the control part, the decisive factor in operational capability, is bound by regulations in the manufacturer. When the control part holds the deciding role, actual ownership is significantly narrowed. Users pay money to buy the vehicle, and you continue paying to maintain the ability to use it, creating an endless loop where you are struggling in futility like a hamster running in its own toy wheel. Are you currently wondering how to free yourself from the grip of this trash sensor pile without waiting for any politician to come to your rescue? The answer lies in shifting your position from a victim to a true master of technology. The problem is not that the system is too complex, it is the way it is operated incorrectly. Number 1, control DEF quality right at the input. Most emissions-related failures do not start with the engine. They start with the quality of the DEF fluid introduced into the tank. This fluid requires a precise urea concentration of 32.5%, and the system is calibrated to detect even minute deviations from the standard value. Small deviation, big consequence. In real-world conditions, DEF can be affected by ambient temperature, storage time, or improper transport. The solution can become slightly diluted or change concentration after sitting in inventory for a long time. These changes are invisible to the naked eye but are enough to trigger system warnings. The solution is to test before use. Use a handheld refractometer to directly measure the DEF concentration at the filling point instead of blindly trusting the supply source. This device provides immediate results and eliminates risks at the input before the fluid ever enters the system. If it doesn't meet the standard, do not use it. This is the most critical control step. Number 2, monitor the system in real time. Instead of waiting for warnings, most users only realize there is a problem when the fault light appears on the dashboard, at which point the system has already entered restricted mode. By then, it is too late. An effective solution is to monitor operating data from the start through devices that read parameters directly from the ECU. Devices like Edge Insight or Scan Gauge allow you to display DPF status, regen cycles, exhaust gas temperature, and system pressure. This is real-world operating data. When the DPF begins to accumulate soot, pressure and temperature will shift before the system issues an official warning. When a regen cycle fails to complete, the data will show the interruption in the cleaning process. These signs appear early. Continuous monitoring helps detect issues before they become system failures. You can adjust your driving to complete the cleaning cycle instead of letting the system trigger forced enforcement mode. Proactive, not reactive. Number 3, adjust operations to maintain stable operating conditions. Modern exhaust systems are designed to operate efficiently when exhaust gas temperatures are high enough and airflow is stable for a sufficient duration. These conditions do not occur when the vehicle only runs short trips or endures prolonged idling in urban areas. This is the cause of buildup. When exhaust gas temperatures do not reach the necessary threshold, soot is not completely burned and continues to accumulate in the DPF. The regen process will be triggered more frequently, but its effectiveness decreases if operating conditions are unsuitable. The system runs continuously but fails to solve the root problem. This leads to recurring errors. The solution is to adjust how you use the vehicle to match the system's design conditions. Maintaining a steady speed during long journeys helps exhaust temperatures reach the optimal level to clean the system naturally. Reducing idle time helps limit unnecessary soot accumulation. Increasing the load appropriately under certain conditions allows the system to achieve higher cleaning efficiency. This is not a complex maneuver. This is correct operation. Number 4, combine operating data with actual maintenance. A common mistake is performing maintenance based on a fixed schedule rather than the actual operating status of the system. The exhaust system does not wear out according to a set time frame. It depends on the specific usage conditions of each vehicle. A vehicle driven long distances has a different soot accumulation cycle than one driven in the city. If you only rely on time milestones, many problems will not be detected in time. The solution is to use operating data to determine maintenance intervals. Monitor DPF status, regen cycles, and system pressure to evaluate the actual condition. When parameters begin to deviate from normal thresholds, that is when inspection is needed. Maintenance at the right time reduces costs and increases system stability. The DEF system is not a random factor. It operates according to clear, predictable rules if you understand how it works. The 3 core elements include input control, data monitoring, and operational adjustment. When inputs, data, and operating conditions are not controlled, errors will appear in cycles and repeat continuously. Conversely, when controlled correctly, the system becomes significantly more stable. You don't need to change the system. You only need to change how you use it. What about those who are about to buy a car? If you are preparing to buy a diesel vehicle, especially used models, this is the most critical moment in your decision-making process. A mistake at this stage will result in ongoing costs for years to come. 1. Technical: do not buy if you cannot check Regen frequency. When inspecting a diesel vehicle, the first thing to check isn't whether the engine sounds smooth, but how the DPF, diesel particulate filter, system has performed in reality. The DPF is a filter that traps soot, and it must clean itself through a process called regen, regeneration, which occurs when exhaust temperatures are high enough during steady driving. If the car has been used correctly, regularly driven long distances at consistent speeds, the intervals between regens will be long and stable. That is the normal state. Conversely, if the vehicle was primarily driven for short city trips with frequent idling or low loads, regens will occur much more frequently but less effectively. This is a clear warning sign. Continuous regeneration indicates that the filter is becoming clogged, and the system cannot thoroughly clean it under current operating conditions. Increased back pressure in the exhaust forces the engine to work harder to maintain power, leading to higher fuel consumption and increased operating temperatures. More importantly, repeated regen cycles can cause unburned fuel to leak into the engine oil, diluting it and reducing its lubricating capability. The failure won't happen immediately, but it will happen. Components like bearings, crankshafts, and oil pumps will suffer over time. And when the fault finally appears, the repair costs are usually massive. Therefore, before buying, you must demand a check of the operating data, specifically the average distance between regens or the DPF history via a diagnostic scanner. If there is no data or if a check is refused, stop the transaction. No further explanation is needed. 2. Legal: do not buy if you cannot access the ECU beyond technical factors. Having access to the central control system is the deciding factor in your ability to control maintenance costs throughout the vehicle's life. The ECU, engine control unit, on modern diesel cars doesn't just manage the engine. It manages the entire emission system and operational protection mechanisms. If access is restricted, every diagnostic and repair step will depend entirely on the official dealer. This is a major risk. Before purchasing, test the system's accessibility using a standard OBD2 device or independent diagnostic software. If the system requires proprietary access codes or prevents basic operations like reading/clearing codes or resetting sensors, the user's control is severely limited. This means every minor fault must be handled at the dealership at a premium price. Dealer labor rates typically range from $150 to $250 per hour. Small expenses accumulate into large ones. A closed system limits competition in repair services, driving prices up. In contrast, an open system allows various independent shops to diagnose and repair, reducing costs and increasing flexibility for the owner. Therefore, you should only choose vehicle models that have a well-developed ecosystem of third-party software and diagnostic tools. Devices like Edge Insight or independent data reading software must be able to access real-world operational information. This is a mandatory condition. Diesel still offers significant advantages in terms of durability and performance. The current shortcomings only become a problem when you lose control over them. However, if you understand them correctly and operate them properly, you can fully capitalize on the value they provide. So do you have any other ways of handling these issues? Please leave a comment to help more people out.